Is it going to be horizontal or vertical? Horizontal, right? Because the X term comes first. So it's going to open left and right. It's good to write that down so you can graph it correctly, okay? Where do you think the center is going to be at? So on all of our other conic sections, it's been the opposite of this number, right? So -2, and then the opposite of this number, which is +1. So we have a center. You're going to go 2 to the left, up 1, put a point. Okay. Then we're looking for our stretches. So we're going to take the square root of 9, which is 3, square root of 16, which is 4. So the 3 is associated with the X, right? So left and right is going to be 3 units. 1, 2, 3, put a point. 1, 2, 3, put a point. And then the Y stretch is going to be 4 units. So from the center, go up 4, and down 4, and put a point. 1, 2, 3, 4, put a point. Okay? You're going to take those 4 points and make your rectangle. Once you have your rectangle, use your highlighter, whatever color you've got. Go corner to corner and draw your asymptote. Okay, so the asymptotes are going to be your guide to draw in your hyperbola. So start at the right vertex and get super, super close to the asymptote. And draw on your right hyperbola and then your left one. And then you're going to write your vertex points down. You should have one on the right and one on the left. So this one is at +1, +1, so 1, 1. And then this one is at 1, 2, 3, 4, 5, so -5, +1. Let's look at our transverse axis and our conjugate axis. So the longer one was 4, double it, so 8. Shorter one is 3, double it, gets 6. And then the foci, we're going to have c squared equal to a squared and b squared. So 3 squared plus 4 squared. Anybody recognize this one as a Pythagorean triple? Anybody get an A in geometry? Perfect right triangle. Well, so the sides that fit perfectly into the Pythagorean theorem is a what triangle? 3, 4, 5. So C is 5 in this case. So from the center, count 5 each direction and put a point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, any questions on 3? All right, number 4, this one's horizontal as well. So it's going to open left and right. The center is going to be where? Nothing's happening here, right? So that's 0.
0, 1.
And then the opposite, so -1. So 0, -1 is right here. What's the denominator of this x squared? 1. So the square root of 1 is 1. So our stretch x is 1 to the right and 1 to the left. Easy. What's our stretch up and down? 4. So 1, 2, 3, 4, put a point. 1, 2, 3, 4, put a point. This one should be tall and skinny, right? So draw on your rectangle. grab your highlighter, draw in your asymptotes. All right, so let's count out where our vertices are at. So they're going to be left and right. So this one is at -1, -1. And this one is at +1, -1. And then we're opening left and right. So draw in your hyperbolas, getting super close, super close, super close, super close. And let's see, our transverse axis is the longer one, which was 4. So double the 4, we got 8. Conjugate axis, our shorter one was 1, double 1, so 2. And then the last thing is we're going to find the foci. So we've got c squared equals 1 squared plus 4 squared. So 1 plus 16, square root of 17. Just a little over 4, right? Because 16 is a perfect square, so I got like 4.1-ish. So from the center, we're going to count just a little over 4 each way. So 1, 2, 3, 4. 1, 2, 3, 4. So roughly right there.